So I live in Miami, and my birthday was right in the middle of RailsConf or RubyConf, and nobody stopped their presentation to wish me a happy birthday. So I was leaving for the airport on Tuesday. This is actually that morning. My neighbors thought I looked ridiculous, and my head was really hot because it was like 80 degrees outside. And I was like worried that Ben would be insufferably weird, that like somebody in the hotel would really, really hate style sheets, and that there'd be like people that I want to hire as a life coach that keep a couch on their porch in the rain just to sort of have a good life. So I'm Bryce. I work at Basho. I work on the React Ruby client. React is a distributed database. So what even is a distributed system? Nobody's really sure, but they're computer systems that don't fit on a single computer. One of their so distributed systems are literally like, they are always broken. Like, they're broken all the time. There's always something that's broken, something that's kind of failing, something that's slow. It's really hard to make them work correctly. They're the kind of system where you have to worry about light cones, which is how events propagate. So I've played a lot of Team Fortress for the last decade, which is a little bit embarrassing. But so the soldier on the left and the sniper on the right, they both have different latencies to the server in the middle. Whenever the soldier pops into view with a sniper, the soldier and the sniper both react as soon as they see it happen. Who wins? The soldier shot a rocket that's going to take time to get there. The sniper fires immediately, and the server has to make a lot of hard choices about which client they trust or which combination of which client's states they trust. And in a lot of cases, something completely incongruous will happen. So I believe in TF2 what will happen is the sniper will shoot, the soldier will die maybe after they've popped back into cover, and then the sniper will explode because a rocket they didn't see hit them. Leslie Lamport, a great distributed systems expert, says that a distributed system is one in which a computer you didn't know existed can make your computer not work. So I'm going to talk a little bit about the rules and theory of distributed systems, what inconsistency and unavailability mean, and how to make your Rails app distributed. So there's a very, very famous problem or thought experiment called the Byzantine generals. And there's two generals that are in valleys on either side of a hill. They both have their armies. They have to attack the town at the hill at the same time, or they'll both lose. And the only way they can communicate this desire is with horse messengers that go right past the town. So whenever they're coordinating times, the first thing is to have one soldier or one messenger go across and say, "We're attacking at dawn." But now the first general that sent the messenger doesn't know if the other general got the message. So now the other general wants to reply. But the town can intercept these horse messengers, and it turns out there's no protocol that covers every possibility of horse messengers getting intercepted. So you have to make a compromise. The problem is a lot of these compromises or a lot of these protocols are self-organizing critical, which means that whenever a little piece breaks, and it's usually part of the safety protocol, breaks, it'll bring the whole system down. So in 2008, Amazon S3 had some single-bit errors in their gossiping protocol between machines that the machines would say, "Oh, there's a single-bit error here, retransmit." And they would just continue retransmitting, errors would accumulate, and they eventually had to bring down all of S3, which made for a really terrible Sunday on the internet. They brought down all of S3 and started it back up again. S3 is really huge. How do you even bring that back up? GitHub in December 2012, sorry Ben, they had a hardware issue on their network. And what would happen is file server pairs would say, "I've been partitioned from my other one. I'm going to shoot the other node in the head," that's the name of the protocol, "and continue operating as master." Unfortunately, they would both shoot the other one in the head, and they would both die, or they would both live and act as master and sort of have a divergent state. And that took a lot of time, I understand, to sort out. And then finally, the power grid in the Northeast US, a little over a decade ago, they had one wire touched a tree during a high load during the summer when everybody's running their AC. The power lines get hot because they move a lot of current. This one touched a tree and cut off, so all that load had to go to other wires in other parts of the network. And they expanded, and they got hot, and their safety protocols cut them off. And long story short, all the traffic lights in New York, Toronto, a lot of stuff in DC, and things as far south as Atlanta were without power because of safety protocols cutting off parts of the system. And back to everything's broken. So at scale, when you have a lot of parts, stuff breaks. At any given time, the Backblaze backup company has 40 dead hard drives. Gears of War 2, very popular game, they had 40,000 hours of playtesting before release. In the first 15 minutes of release, there were more players that had put time into the game than they had playtesting, and they found new bugs that hadn't been discovered yet. And really the big thing in distributed systems is the CAP theorem. Consistency, availability, partition tolerance. You pick two, but you're always going to have partitions, so you have to pick that one. In conclusion, distributed systems are a land of compromise. So let's talk about the CAP theorem a little bit more. Your system will have partitions. There's a great blog post by Kyle Kingsbury, also known as AFER, called "The Network is Reliable," and it's all about how the network is not reliable. So you will have partitions. Do you want to sacrifice everything being correct or working at all? If you want to sacrifice working, Apache Zookeeper is a fantastic project that lets you get a quorum and make sure that your data is correct or your data are correct. What in Apache Zookeeper, you would run like an odd number of nodes ideally in lots of different data centers. And if you lose some data centers, as long as you have a majority working, they will continue to serve requests, and the minority will just fail and say, we don't have a quorum, we can't work. So whenever you don't fill requests, that's actually a really valuable property to have. So if you're trying to sign up a new Twitter account, you don't want to claim somebody else's username, and Twitter would rather you not sign up at all than steal anybody in this audience's username. On the flip side, we also have React, which is an AP system. When React loses a quorum, it'll still accept writes, and it'll perform reads. The writes should eventually, become durable and persist to every node. The reads will probably be wrong answers, but sometimes it doesn't really matter. Like if you're looking at a YouTube video and you're wondering why it's been viewed fewer times than people have liked it, it's just because the view count isn't important, and YouTube would rather record likes, record reads, record views, etc., and have them be momentarily wrong and eventually correct than have them not work at all. Both of those are really, really crappy. You really want like a hybrid setup where you have multiple different data stores that have different semantics for the different situations you have. So you can have consistency where you need consistency, like for Twitter usernames, and you can have eventual correctness, like with tweets themselves. And I swear this is my last plug. React 2, which will come out soon-ish, will have both the existing weak consistency and strong consistency. So last up is distributed Rails, which you're already distributed. So whenever somebody signs up for your app, they probably type in their username, type in their email address, they click sign up, and you send them a confirmation email, right? What happens when you've committed the transaction to Postgres, but the transaction completion never gets from Postgres back to your Postgres client? Do they get the welcome email? Probably not. Do they get a 500 error from your Rails app? They do. What they're going to do is they're going to hit reload, they're going to click continue on that awful resubmit the form dialog, and they're going to get a username already taken error. So what you thought your Rails app looked like was just this neat little box, Rails, where you get validate uniqueness, you get your after callbacks. But it's more like this. Sometimes you lose database connection after or in the middle of a transaction. Sometimes everything fires, but the user loses connection. They turn on airplane mode, or they go, out of cell coverage. And a really, really powerful way to deal with a lot of this is to put as much business logic as possible in your SQL database. Rules is either a noun or a verb here. You can enforce correctness in SQL. I've had a lot of problems where I do validate uniqueness of, but I don't put the index in SQL, and it causes problems for me, a week later when something double submits. And SQL is a really, really great language for writing your business logic in. However, SQL makes some guarantees called ACID that rely on the fact that most SQL systems are consistent and partition tolerant, but not necessarily available. With NoSQL, you get a lot of flexibility because nobody expects NoSQL systems to be ACID. They actually use a separate set of rules called base, which is like basically available, kind of soft state, and eventually consistent. But NoSQL systems in general are not programmable to the extent that SQL is. So you can't rely on your data store enforcing all your business logic. So there's a big temptation to put all the smarts of your app into its model classes. This is called a monorail. So Twitter famously, they started as a Rails app, and they continued building a Rails app. And what happened was their app got bigger. They kept having issues where people were trying to work in the same model, and it wasn't scaling. It may have scaled computationally, but it wasn't scaling organizationally. And what sort of happens there is you want to move off of the monorail and go to a service-oriented architecture, which sounds scary. It sounds really Java. But it's not necessarily. It's sort of extending the solid principles of like single responsibility, et cetera, from individual objects in your application or individual classes to services that manage one thing. So think about the user class for your like really, really important application. Is it more than 50 lines? Is it more than 100 lines? Is it more than 1,000 lines? So your user class is not, it provides more than one service to your application. It provides check your password against bcrypt or scrypt. It provides user profile fields. It provides uploading a new avatar, which I need to do more often. It provides so many different services, and it doesn't make sense for all these services to tie back to the same model. So username uniqueness, you could put that in the same database as everything else, but it may make sense to have that in a sharded MySQL or a sharded Postgres, while your profile fields are bigger, they're bulkier, and they don't necessarily need to be in this sharded database that may be really expensive. You could put them in something cheap. You could put them in Memcached sometimes and Redis sometimes, and eventually have it go back to some cheap sharded storage. So you could keep growing your model. You could break that model into lots of pieces, but you really, really want databases or different services that act as kind of a database for different services that the user model provides. So then you want to extract the different parts of your app. So if you're Twitter, you know what your most painful thing is. It's scaling to zillions of tweets. And that's the really most natural thing to extract from your app. You want your tweet storage to be a separate app from your user profiles, your following, your hashtags, etc. So what you do from there, you figured out what you want to extract. You come up with the verbs and the nouns that you want to discuss with your separate service that is in your distributed app. So you'll have get a tweet by ID, maybe do a full text search on tweets, post a tweet, and you'll have some sort of protocol for errors, what if this user posted the same tweet 5 seconds ago? What if this tweet looks spammy based on previous tweets? So you document these protocols that you have in your app and not really documented already. You document these protocols, you write some tests, you build this service. What does that get you? You get smaller deployments. So if you have a 2009, 2010 era Rails app, you run Capistrano for 20 minutes, and your app eventually shows up, and all your users get shunted off all at once. One of the goals of service-oriented is to have a smaller deployment, where you would just deploy a new tweet service to like 1% of your machines, make sure it doesn't fall down, make sure the error rate stays stable, and continue deploying it incrementally. How do you test this? We write the same unit tests you were doing already. You write higher level service tests that make sure the service runs as expected. But then you have acceptance tests. And you can't really acceptance test a machine or a system that runs on hundreds or thousands of computers. So what you do is you instrument parts and just deploy it to part of your user base. Win Netherland at Big Ruby in Texas 2 weeks ago did a presentation about how they refactored GitHub with Science. And they put lots of little probes to measure things in. They do like behind-the-scenes A/B testing, where they'll deploy a new version of a method or something, and they'll run both the new version and the old version in parallel, return the old version that they know works, and log if the new version returns something different, which lets you help make informed decisions about what works and what doesn't without inconveniencing your users or having to test some like really huge system independently. And I have a link to all these at the end. So working offline is really just kind of a special case of working online. I don't run a web server on my iPhone, so I have to deal with like latency to every online website. Sometimes individual machines stop for garbage collection and quit responding. I work on airplanes sometimes, and it always makes me like really bummed out when Google Drive didn't set up offline mode correctly, and then I have to, use just a text editor. And packet loss is always like a big demon. So everybody, like the way you get around this is making a smarter client, which you're already doing. A lot of people, me more often now than I used to, get tired of like the click buttons, screen goes white, new HTML loads. TurboLinks is built into Rails now, Ember, Backbone, etc., super popular. So you already have a smart offline app. What the big move is to make it work properly offline is like recording information and dealing with the inevitable conflicts. So did anybody here ever use Google Wave? So I saw like 3 or 4 hands. It's my alarm. So Google Wave, they made a operational transform protocol, which sounds complicated, and it kind of is. But how it generally works from a high level is whenever you type stuff on the smart client, the JavaScript shows you your changes immediately and sends a copy of the operations to the server. The server then takes all the operations it's receiving from clients, replays them in a way that makes sense and can produce a coherent result, and then sends both the result and the collected operations to the clients. And what that allows is for the clients to get real-time updates based on what they're doing, which is important to feel interactive and feel good to a user, but they also get everybody else's updates. So even though Google Wave is mostly dead, they still use the same technology in Google Docs, where you see lots of cursors moving lots of stuff around the screen. The other really big offline app is Git. And with Git, you make a lot of changes, but it does a really good job of naming these changes, and it also has a fallback to where users pick whichever version that if the computer can't figure it out. And the final big offline app that I've been reading a lot about is Vesper. So it's made by some celebrity, for lack of a better term, iOS developers. And what they do is they make sure that the offline client that they control, because it's an iOS app, can name changes independently. They can merge stuff on the server if it makes sense to merge. They try not to lose data, and they figure that users would rather have a duplicate set of data than lose data at all. So that's the 3 main topics I wanted to hit, and I went way too fast. So from a high level, Ruby works. If you're building a distributed system, you don't need to switch to some JVM language you don't understand that has lots of weird punctuation. The most important thing is to build something that people want to use. Every complicated system that works grew out of a simple system that works and not a complicated system that didn't work. So you can grow this stuff incrementally one day at a time. If you have a bottleneck here, work on easing up that bottleneck. Don't work on, destroying the whole code base and starting from scratch. You can definitely grow your system when you need to. And that's all I have except for a lot of bonus slides. So all my links are at that bit.ly link, bit.ly/ROA-dist. And I'm BonzoEsk on Twitter. So any questions so far? Yes?
So I get to work on a service-oriented architecture, and one of the interesting problems is not just like deployments, but also handling like versioning within the services, and that gets pretty complex and pretty difficult to handle.
Okay, so the question was, when working with distributed systems, not only do you have lots of deployments, but you have lots of parallel versions, and you have to worry about versioning different APIs, correct? And how do you handle that? The same way places handle it with their REST APIs, and I'm not saying that you have to build your distributed services or your service-oriented architecture all REST, but a little version field goes a long way, or having some sort of organizational method where you say, we're releasing version 2 of the tweet service. By the end of the month, we're going to break all the 1.0 clients. So start switching them over now. And it feels more like an organizational problem there because it is. And I don't have a particularly satisfactory answer about getting rid of old versions, but other than maybe designing your protocols so you don't need to get rid of old versions. But that's really hard. Any other questions? So I'm going to throw out just a couple other terms and other notes I took. So another way of looking at the CAP theorem is harvest and yield. So harvest is how much data you'll get back from a particular request, and yield is how likely it is that the request will succeed. One of the things you lose when going distributed is auto-incrementing ID columns. And the problem there is that I'm busy writing to this table, and somebody else is already waiting for the ID to increment before they can write to it. And what Twitter does is they use a tool called Snowflake to generate guaranteed unique IDs that are still loosely orderable enough to work for storing tweets in a row. And SQL's on ACID, NoSQL's a base. And there's lots of other reasons to extract services. And a few offline databases that I couldn't find a lot of people that were super satisfied with them. And they all sort of have a CouchDB-like API in your JavaScript. And finally, this Jeff Hodges presentation from Recon West 2013 called The Practicalities of Productionizing Distributed Systems is fantastic, and it's in the big set of bit.ly links. Anything else? And let me go back to the bit.ly. All right, thanks.
Hello, everybody. Thank you, Bryce. That was some sage advice there. Build stuff that people want to use. I do not do that. Now I know what I have been doing wrong this entire time. Also, I noticed you had up there, did you mention something about a life couch?
A life...
The life couch? Yes.